Hey guys, welcome to our video today. You can see I have my friend up here watching you. He's your friend too. He's going to be watching you closely throughout this lesson to see if you're paying attention and you're listening. Because if you don't, he's probably going to call me on my phone, but I'm probably busy helping someone else right now, so make sure you follow along and pay attention, okay? We're doing estimating sums and differences of whole numbers and decimals. So estimating sums and differences. You know that anytime you hear the word estimating, you're going to be dealing with rounding. That's right, rounding, which you should already know. So I have some key words over here for you. Estimate, overestimate, and underestimate. So we'll talk about these two things later, but let's focus on estimating right now. So if you have, let's say we're adding first. Let's do whole numbers adding. 33 plus 47. What you do is it's important to you that you round each addend. These are addends, the things that you're adding together. It's important that you round those before you solve the problem. Everyone say before you solve the problem. Good. So you're going to automatically know that 30 rounds to, you can't really round it to the nearest ones place because there's no decimal, so you're going to round it to the nearest tens place. That's the easiest thing to do. Usually when your problem says estimate, it's not going to tell you round this to the nearest tens or round it to the nearest hundreds or thousands. You get to choose which one is easiest for you. I'll say that again. It's not going to tell you what to round it to. You get to choose what you want to round it to, whatever's easiest. So for me, it's easiest to round these two by tens, or to the nearest tens place. So I'm going to round 33 to 30, because 3 is less than 5, so this stays a 3 and this turns to 0. 3, 0. Now 7 is 5 or more, so you're going to round 47 up to 50, because obviously 47 is closer to 50 than it is to 40. So 30 plus 50 is the new problem, and you can solve that mentally. It equals 80. Good job. Well, hopefully good job if you got that right. If not, take a look again. 30 plus 50 equals 80. Let me see if there's anything else I want to tell you about that. I don't think so. You don't have to write this. You can do it in your head, but at first it might be easier to write down the problem. But you could just know in your head, this is 30, this is 50, add it, it's 80. That's your choice. Let's do a harder one. Let's get up into the hundreds. Let's do 281 plus 327. Now to me, it's easiest to round these to the nearest hundreds place. I don't have to do tens, because if I round it to the nearest tens place, I might not be able to do it in my head. And the whole reason for rounding is to make it easier for you. It's just an estimate. So 281, is that closer to 200 or 300? Closer to 300. And you know, because if you're looking at the hundreds place, look to the right. 8 is 5 or more. It's more than 5. So you change the 2 to a 3. Everything else goes to 0. 327 is closer to 300. And you know, because look at the hundreds place, then bump over. The 2 is less than 5, so you leave the 3 the same. Everything goes to 0. And it equals 600. Remember, it's not going to tell you which place to round it to. You get to decide whatever's easiest for you. Let's do subtraction. Really quick. Okay, my guy's looking at you. I think he says you're doing a good job. So, good for you. Let's do subtraction. Let's do a 1,764 minus... actually, let's change it. Let's do 3,764 minus 1,321. Again, it's easiest for me to to round it to the thousands place. So I'm just going to round this. Is it closer to 3,000? Closer to 4,000? I know that it's closer to 4,000 because if I'm rounding to the nearest thousands place, I'm going to look to the right. The 7 is more than 5, so he automatically goes up to 4,000. Whoops, we're subtracting. And this is going to round down because it's closer to 1,000 than it is to 2,000. 4,000 take away 1,000 equals 3,000. Very good. All right, so it's the same thing with subtraction as it is with addition. Now we're going to do decimals quickly. Decimals. So 3.7 and we'll add first 2.1. I want to round this to the nearest whole number because that's really all I can do. The nearest whole number is the ones place. So you're going to look at the ones place and look over to the right at the tenths place. This is either going to be closer to 4 or closer to 3. And since I have a 7 right here, that's 5 or more, so the 3 turns into a 4. You really just pretend that the decimal isn't there, because I know sometimes you look at the decimal and you don't know if it's okay to cross over and look at the 7. It is okay. Look to the right of whatever number is here. This is your whole number. Look to the right. It either goes up to 4 or stays at 3. We decided it goes to 4. So you're going to add. I'm looking at my 2. I have 2.1. 1 is certainly less than 5, so he stays at 2. There's no more decimal anymore because you changed those to zeros. So if you want to make it clearer, you could do 4.0 and 2.0, but it's unnecessary. 4.0 plus 2.0 is 6, or 6.0. 6 is exactly the same as 6.0. You don't need to do that, but just so that it's clearer, that's what it's going to look like. It's the same process as rounding whole numbers, except for there's a decimal in the middle. It's almost always going to be easiest to round to the nearest whole number when you're estimating decimals. So let's try again. Let's do subtraction. Subtraction. I'm still going to round to the nearest whole number because I don't want to deal with what's over here on the decimal. It's going to be too tricky for me, and I'm probably going to have to write it down again anyways, and I don't want to do that because I'm just estimating. It should be easy. So 4.88. Do you think that's closer to 5 or closer to 4? We can check by looking at the whole number. Rounding to the nearest whole number is rounding to the ones. Look to the right. Just him is all you're worried about. Is he 5 or more or less than 5? He's 5 or more, so you change 4 to a 5. He moves up. Again, you can do 5.00, but it's unnecessary. You can just do a 5. Take away, or minus, 2.91. We're rounding to the nearest whole number, so I look at the 2, bump to the right. It's a 9, so he changes up to a 3. Everything else goes to 0. Subtract. It's a 2. Now I'll say this once. Whenever you're subtracting or adding decimals, you have to make sure your decimal matches each other, that they're lined up right on top of one another. Otherwise your answer will be incorrect. Whenever you're adding or subtracting decimals, make sure these match and they're in the same place. Let's talk about overestimate and underestimate. If a word problem asks you, is your answer, after you've rounded and solved already, it's going to say, is your answer an overestimate or an underestimate? An overestimate means that you mostly rounded up. Underestimate means that you mostly rounded down. So looking at this problem, in both the cases we rounded up. We rounded 4.88 to 5, so we rounded up. We rounded 2.91 to 3, we rounded up. So 2 is going to be more than the actual answer. And I'll show you, because I'll subtract this. I'm going to do real subtraction, not estimating, just to prove to you that this is an overestimate. We got to borrow. It's barely over. Hopefully I solved that right. Let me know if I didn't. It's barely over, but it is still more than 1.97, 2.00. That was a pretty good estimate. It's almost exactly the same. It's only 0.03 different. But you can see that this is an overestimate because it's more. Let's try to do an underestimate. Let's do 3.36. Take away, well, let's add this time. 2.47. 3.36 rounded to the nearest whole number rounds down to 3. Or 3.00, up to you. We're going to add it to 2.47 rounds down because 4 is less than 5. 2.00. So now we've rounded both of them down, right? So it's going to be an underestimate because your real answer is going to be a little bit more than what this one is. So our estimate is under the actual answer. So let's add, this is 5. Notice my decimals are perfectly matched. Now let's add these. It should be more than this. Let's try. Decimals match. Just bring it on down for addition. 5.83. It's more than 5. That's considered, this would be an underestimate because it's going to be under the actual answer. Okay? So we have the word estimate. That means you're going to round. Whatever you're doing, you're going to have to round first before you solve. Overestimate means that you rounded mostly up. You could have rounded one up and one down, but the one that you rounded up, there's a bigger difference between the actual number and the one you rounded to. Okay, that's a little confusing. I'll explain more in person. Underestimate is when you rounded mostly down. All right, that's how you estimate sums and differences of whole numbers and decimals. How'd we do, little buddy? He says good. All right, guys. Good job.